everyone, welcome back. It's great to have you here today. In this video, we are going to go through this paper together. Before we dive in, please make sure you have had a go at these questions. Okay, now let's get started. Okay, so now let's look at the first question. We are given fx is 4x plus 6, and we wanted to find f negative 3. So what we need to do is for lots of negative 3 plus 6, which is negative 6. Now in second part, what we need to do is to find the equation of the line that is perpendicular to y equals 4x plus 6 and also passes through the point 0, negative 8. So what we have here is the equation y equals 4x plus 6. If it's perpendicular, that means the gradient should be negative reciprocal, which is negative 1 over 4. So the equation is in the form of y equals negative a quarter x plus c. Now this point here is already the y-intercept. So we know c is going to be negative 8. Moving on to the next one, we are told that the point A has the coordinates A, 10, and B with the coordinates 3b. And they are both on the line y equals 4x plus 6. And we will need to find the length of AB. Now what we need to do is to first find out what is the value of A and B. We know the point is on the line, therefore we can substitute the points back into the equation. We can solve for A, which is 1, and we do the same for point B. We can find out that B is 18. So A is 110, B is 318. To find the length of AB, what we need to do is to find the difference between the x coordinates and the difference between y coordinates using Pythagoras theorem to find the length of AB. And we have root 68. Now in the question, it says leave the answer in the form of c root d. So that means we need to write this surd as mixed surd. 68 is 4 times 17, which is 2 root 17. Okay, now moving on to the second question. In part 1, we need to simplify root 18. Well, 18 is 2 times 9, therefore root 18 is 3 root 2. Root 8 is 2 root 2 plus root 18, which is 3 root 2. We will have 5 root 2 subtract 3 as our final answer. In the third part, what we have is root 2 plus 6 in the numerator. Now we know the denominator is 5 root 2 minus 3. This is what we have in part 2. And what we need to do now is to rationalize the denominator. So what we need to do is to multiply the denominator and the numerator by 5 root 2 plus 3. This is because we can use the difference of 2 square to get rid of that root 2. So what I'm going to do here is to show you what that will look like. By using Farmer's field, we can work out that 5 root 2 subtract 3 times by 5 root 2 plus 3 will give us 41. Now we will use the same method to expand the bracket in the numerator. Root 2 plus 6 times 5 root 2 plus 3 will give us 28 plus 33 root 2. Okay, so now we are given first a few rows of Pascal triangle. And we know that third row gives us the coefficient of bracket squared. The fourth row will give us something to the power of 3. Therefore, we know that to expand e plus f to the power of 3, we will have e to the power of 3 plus 3e squared f plus 3ef squared plus f cubed. Moving on to the next part, we are given the expansion of e plus f to the power of 4. We are asked to work out this calculation. So by comparing the letters and the numbers, we know that e is 7 and f is 3. So this is the expansion of 7 plus 3 to the power of 4, which is 10 to the power of 4. That's 10,000. Now we need to expand and simplify 2e plus f to the power of 4. We know that this row here is the coefficient, so we are going to write it down. We know that the power of 2e is going to go from 4 to 0, or if you want to do it the other way around, doesn't matter, we will get the same answer. F, on the other hand, will go from 0 to 4. So what we need to do now is to simplify. Now 2e to the power of 4 is going to be 16e to the power of 4 when we get rid of the bracket. 2e to the power of 3 is going to be 8e cubed, and then 4e squared, 2e. So in the end, what we need to do is to add them together and make sure that the coefficient are multiplied together. Okay, so now moving on to indices. 81 to the power of 3 over 4, we can write it as a quarter times 3. So fourth root of 81 to the power of 3 is the same as 3 cubed, and that is 27. If we have 1 over, that is to the power of negative 1. So 1 over 9 squared is 9 squared to the power of negative 1. Well, 9 is 3 squared, so it is the same as 3 squared squared to the power of negative 1. That is 3 to the 4 to the negative 1, which is 3 to the negative 4. Moving on to next part. Now we know in part A, 81 to the power of 3 quarters is 27. 1 over 9 squared is 3 to the negative 4. So what we have here is that we have two numbers with the same base. What we have here is 3 to the 2y plus 1 times 3 to the negative 4 can be written as 3 to the 2y plus 1 take away 4, which is 3 to the 2y subtract 3. Now 27 and 27 to the negative 2 over 3 multiplied together, we add the power, which will give us 27 to the power of a third. Now 27 to the power of a third can also be written as 3 to the power of 3 to the power of a third, and that is 3 times 3 to the power of 2y subtract 3. Okay, again, by adding the indices, we will have 3 to the power of 2y subtract 2. And then 2y subtract 2 is going to equal to 3. Y is going to be 5 over 2. So in question 5, what we needed to do is to prove this circle theorem. We are given the circle. We are told that ABC are the points on the circumference. O is the center. We needed to prove that the angle subtended by the arc and the center, which is angle BOC, is twice the angle subtended at the circumference, which is angle BAC. What we are going to do now is to connect the point OA. We will create two triangles. If we call angle OBA X, we know angle OAB is going to be X as well. It's because this triangle OAB is an isosceles triangle. Similarly, if we are going to call OCA Y, the angle OAC is going to be Y as well, is because this triangle is also an isosceles triangle. Therefore, angle BAC is going to be X plus Y. Now, in triangle OAB, we can work out the final angle AOB is 180 subtract 2x. Similarly, we can work out the angle AOC is 180 subtract 2y. Therefore, angle BOC is going to be 360 degree, subtract 180, take away 2x, subtract 180, take away 2y. By expanding the brackets, we'll have 360, take away 180, plus 2x, take away 180 plus 2y. So we'll have 2x plus 2y, which is 2 lots of x plus y, which is 2 lots of angle BAC. Therefore, we have proved the theorem. Okay, now moving on to question 6. We are told that the point Q has a coordinates negative 2, 0, and this point is on the curve fx. They didn't tell us what the curve is, and they told us the curve has been transformed, and we are given the function fx plus a plus b, and that moves the point P, which is 0, 0, the origin, to 3, 4. So that means we will have to go 3 to the right, 4 up. Okay, now what we need to work out is coordinates of Q. Coordinates of Q is negative 2, 0. We need to move 3 to the right, 4 up, and then our coordinates is going to be 1, 4. Now we need to work out the value of A and B. So we know if I move the curve to the right, it's going to be subtracting 3. And then if I move the curve upwards by 4 units, it's going to be plus 4. So A is negative 3, B is 4. The transformation K G dx plus 1 move the points R from negative 3, 2 to negative 6, 7. So from negative 6 to negative 3, we know we have to times by a half. Therefore, D is going to be a half. Now from 2 to 7, we know we have to multiply 2 by k and then plus 1 to get to 7. Then that means k is going to be 3. Okay, now moving on to the next question. In this question, we are told that the circle has a center 0, negative 3, and the circumference is 4 pi. Circumference of a circle is pi d, which is 4 pi. Then that means d is going to be 4, therefore the radius is going to be 2. So we can get a sketch of the circle centered at 0, negative 3 with a radius of 2. Okay, now next question, we are told that the line L has equation 2x subtract y equals 5. And what we need to do is to find the coordinates of the points of intersection of C and L. The equation of the circle is x squared plus y plus 3 squared equals 4. The line is y equals 2x subtract 5. We want to find the points of intersection. That means we need to solve this simultaneous equation. Now we know y is 2x subtract 5. What we can do is to substitute the second equation back into the first equation. We will have x squared plus 2x subtract 2 squared is 4. Expanding the brackets and collect the like term, we will have the equation 5x squared subtract 8x equals 0. Now we can factorize out x, and we know x could be 0 or 8 over 5. If x is 0, by substituting this value back into the second straight line equation, y equals 2x subtract 5, we find out y is going to be negative 5. If x is 8 over 5, then y is going to be negative 9 over 5. So for this question, we have two intersections. Okay, now moving on to question 8. In this question, we are told that Alex is standing on a tower and throws a ball to Chris, who is standing on the ground. The motion of the ball is modeled by this quadratic equation, and s is the height of the ball above the ground in meters, and t is the time in seconds. Now we need to write down the initial height of the ball. The initial height is when t equals 0, which is 7. In part B, they want us to explain why this model is not valid when t is 5. So let's see what happened when t is 5. When t is 5, s is going to be negative 18, which is smaller than 0. Now this is a problem because s is the height of the ball above the ground. It cannot be 0, so that's why this model is not valid. In part C is to work out the maximum height of the ball. So what we need to do is to find the maximum point, which we can do by completing the square. What I'm going to do now is to factorize negative 5 out of the first two terms. We will have negative 5 t squared subtract 4t plus 7. Now we need to complete the square in the square bracket. By expanding the square bracket, we will have negative 5 lots of t minus 2 squared plus 20 is because negative 5 times negative 4 is 20, and then the maximum height is going to be 27. Chris catches the ball when it is 2 meters above the ground. So now what we need to work out is the total amount of time the ball is in flight. So we know s now is 2. We are going to set that equal to the quadratic equation. By factorizing out negative 5, we have negative 5 t squared subtract 4t subtract 1 is 0. Now what I can also do is by saying that a is negative 5, b is 20, c is 5, and using quadratic formula. Problem with this is a non-calculator paper. I probably don't want to use these big numbers, especially if I know there is a common factor of 5 I can take out. So what I can do is factorizing out negative 5. Looking at the bracket, I know a is 1, b is negative 4, c is negative 1. By using quadratic formula, we can find out t is 4 plus minus root 20 over 2. By simplifying, we will get 2 plus minus root 5. And because t is greater than 0, therefore t is 2 plus root 5. And that is our final answer. Okay, so now moving on to the next question, question 9. This is a vector question. We are told that OA is 2A, OB is 3B, C is a point such that AC is 5 over 3AB. So that means AB is divided into 3 parts, and then AC is 5 lots of that. So we can complete the diagram to show where C is. Now D is a point such that AD is XA plus YB. Now we don't know what is X, what is Y. CD is negative 2 over 3XA plus 13 over 33YB. Okay, so what we can do now is to work out AB. Now AB is AOOB. That is going to be negative 2A plus 3B. AC is 5 over 3 of AB. So we can work out AC to be negative 10 over 3A plus 5B. We are also told AD. We don't really know where D is, but it doesn't matter. We can just say, well, assume D is here. We know that this vector is XA plus YB. And then CD is going to be negative 2 over 3XA plus 13 over 33YB. And then we need to find the ratio OB to BD. Now we know what is OB, which is 3B. We need to find BD. Okay, so first we know CD is CA plus AD, which is 10 over 3A subtract 5B plus xa plus yb. By collecting the like term, we will have 10 over 3 plus xa, negative 5 plus yb. Now in the question, we are also told that CD is negative 2 over 3xa. So that means 10 over 3 plus x is going to be negative 2 over 3x. Negative 5 plus y is going to be 13 over 33y. By solving the equation, we can find out x is negative 2, y is 33 over 4. Okay, so now from the question, we know OB is 3b. BD is B to A to D. So we can work out BA plus AD. Now BA is negative of AB, which is 2A subtract 3B. Now AD we know is XA plus YB, where X is negative 2, Y is 33 over 4. By expanding the bracket and collect the like term, we work out BD is 21 over 4B. Now to work out the ratio of OB to BD, it's going to be 3 to 21 over 4, which is the same as 12 to 21, and then we can further simplify that to 4 to 7. That's it for today. Well done for making it through to the end, especially if you have done the questions yourself. Remember, maths isn't a spectator sport, and we have to keep practicing to be more fluent. Happy revising, and I'll see you in the next video.